Look around you. Everything you see, your hands, the earth, the stars, is made of matter. But why does anything exist at all? Why is there something rather than nothing? This is one of the greatest mysteries in cosmology. Our existence defies the neat symmetry of physics. After the Big Bang, the universe was a hot soup of energy, spawning equal amounts of matter and antimatter, cosmic twins destined to destroy each other. When matter meets antimatter, they annihilate in a flash of energy. If the universe started with perfect balance, everything should have vanished, leaving only light. But that's not what happened. We're here. The fact that matter survived means the rules weren't perfectly fair. There must have been a tiny imbalance. Maybe for every billion antimatter particles, there was one extra matter particle. After the Great Annihilation, those rare survivors became everything: stars, galaxies, us. The universe is built from the leftovers of a cosmic battle. But what caused this imbalance? That's the puzzle scientists are still trying to solve. The answer could reveal why anything exists at all. Our very presence is the ultimate clue. The search for that answer is one of science's greatest adventures. Let's travel back to the first second after the Big Bang. The universe was a storm of matter and antimatter, created and destroyed in equal measure. As things cooled, particles and antiparticles found each other and vanished in bursts of energy. If the numbers were perfectly matched, nothing would remain, just empty space and light. But we know that's not the case. The fact that matter exists means the initial count was off by just a tiny amount. This tiny excess is the reason we have galaxies, planets, and life. The standard model of physics can't explain this imbalance. It predicts a universe of light, not matter. Something tipped the scales, breaking the symmetry. Finding that something is the key to understanding our origins. Scientists have searched for decades for the reason matter survived. Particle accelerators like the Large Hadron Collider recreate the early universe, hunting for clues. One suspect is CP violation, a tiny asymmetry in how particles and antiparticles behave. It was a Nobel-winning discovery, but the effect is too small to explain our universe. The numbers don't add up. The known flaw isn't enough. This means there must be new physics, unknown particles or forces that break the symmetry more dramatically. Maybe heavy, unstable particles from the Big Bang decayed in a way that favored matter. Or perhaps there's a new force we haven't discovered. The search continues, pushing the boundaries of what we know. Somewhere there's a crack in the standard model that holds the answer. Enter the muon, a heavier cousin of the electron, sensitive to the quantum world. At Fermilab, scientists measured how muons wobble in a magnetic field, a prediction made with extreme precision by the standard model. But the muons wobbled faster than expected. The difference is tiny, but it's real, and it can't be explained by current physics. This suggests muons are feeling the influence of unknown particles or forces. It's a crack in the foundation of physics, a clue that something new is out there. The same unknown phenomenon could be responsible for the matter-antimatter imbalance. The muon's extra wobble is a breadcrumb, leading us toward new physics. It's one of the strongest hints yet that the standard model is incomplete. The answer to why we exist might be hidden in this tiny anomaly. The search is on to uncover what's behind the muon's mysterious behavior. This could change our understanding of the universe. Sometimes the smallest clues lead to the biggest discoveries. The muon's wobble could be the missing piece in our cosmic puzzle. If new particles or forces are at work, they might explain why matter survived the Big Bang. Scientists are racing to confirm the anomaly and build new theories. We may be on the verge of rewriting the rules of the universe. The standard model was never the full story. It can't explain dark matter, dark energy, or gravity. Now, we have a direct clue pointing beyond it. The journey to understand why we exist is far from over. In fact, it may have just begun.